We're using Solver in Excel to solve the International City Trust problem. This is an example of the use of linear programming for portfolio allocation. We're told that we have up to $5 million to invest, and obviously we want to maximize the return that we're getting on that investment. We have 6 options for instruments to invest in. We have trade credits, corporate bonds, gold, platinum, mortgage securities, and construction loans. And we've been told what return we can expect from each of those investments. So that's the first thing I'm going to fill in. The return that we can expect from trade credits is 7%. From corporate bonds, it's 10%. From gold, it's 19%. Platinum is 12%. Mortgages are 8%. Construction loans, 14%. So we're ready to write our objective function. Our objective function is, what will the return be? We're going to be solving for how much money we should invest in trade credits. So it's going to be however much we invest in trade credits multiplied by the 7% return we expect, plus however much we invest in corporate bonds multiplied by the 10% return we expect, the amount that we invest in gold times the 19% we expect to get a return for gold, and so on. You'll recall that we're using the formula sum product. What we want to do is tell it to take range B6 through G6, and we want to multiply and add the results from cells B5 through G5. You'll recall that once we write this formula, we can copy it down for all of the other constraints. But before we do that, we need to lock in B5 through G5. No matter where we copy this formula, we want it to keep B5 through G5 constant. I'm going to highlight it and I'm going to click F4. You're welcome to add the dollar signs individually if you'd like. It's called absolute addressing, and what we've done is we've locked in B5 through G5. I'm going to hit the enter key, and now I'm going to take that value and I'm going to copy it down for all of the constraints. You'll recall that we want to copy the formula, not the formatting. So when I do a paste, I'm not just doing the regular paste, I'm doing the paste formulas. What that does is it pastes the formulas, but it leaves the blue default formatting constant. Now that we've written the constraint, now we're ready to come in and actually write the value constraints. The total fund, the total amount that we have to invest, has to be less than or equal to $5 million. So however much we invest in trade credits, I'm going to fill in a 1 here, multiplied by however much we invest in corporate bonds, multiplied by 1, plus however much we invest in gold, multiplied by 1. I'm going to fill 1s all the way over, because really what I'm doing is I'm using them as a surrogate value for the dollar invested amounts from up here. The amount that we invest in all of those instruments has to be less than or equal to $5 million. Now we do have constraints that we've been given about how much we can invest in any one individual instrument. The maximum amount that we can invest in trade credits is 25% of our investment. I'm going to fill the 1 in just for trade credits, because I want to take however much we invest in trade credits. Doesn't matter, corporate bonds, gold, platinum, mortgages, construction loans. This constraint is only about trade credits. It has to be less than or equal to 25% of what our investment is. So let's think about this for just a second. It's going to be 25%. So let's write the formula, 25%. How much is our investment going to be? We have up to $5 million to invest, but we don't necessarily have to invest all $5 million. It could be that given the constraints that we have, we're going to invest $4 million and the other $1 million we're going to hide in the mattress. So it's 25% of how much we're actually going to invest. That's in cell H8. The actual amount of money that we are going to invest is in H8. And H8 is going to be less than or equal to $5 million. So anytime we have a constraint about the percentage of how much we invest, we always have to make sure that we are writing that constraint off of cell H8. So we have that constraint for corporate bonds, for gold, for platinum, for mortgages, and for construction loans. Before we take this formula and copy it down, what is it that we have to do to it? We always want to multiply by H8. So we're going to take H8, I'm going to highlight it and hit F4. That's the quick way to put absolute addressing on. But we need to lock in H8. No matter where I copy this formula to, always use H8. So now I can copy it down for all of the instruments. Risk score is what we have to fill in for our constraint next. You'll notice that each of these investments have a different risk score, and we want the average risk score for the whole portfolio for everything that we're investing to be a 2. So we're going to invest in some things that are over a 2, some things that are under a 2, but we want the average risk score to come out as a 2. Sometimes people struggle with that a little bit, so what we're going to do is take a look at a simpler example. Let's say we only have $1,000 to invest, and we have the choice between stock A and stock B. Stock A has a risk score of 1, stock B has a risk score of 3. If we want our average investment, our average risk score to be a 2, I think we can kind of look at that and just intuitively say, well, if we put $500 into something with a risk score of 1, and we put $500 into the risk score of 3, that our average investment is going to have a risk score of 2. Why don't we look at the algebra just for a second for how we solved that? What we did is took the dollar amount and we multiplied it by the risk score for stock A, which is 1, plus the $500 multiplied by the risk score for stock B, which was 3. That didn't equal $1,000. What it equals is the total investment, the $1,000, times the risk score of 2. Let's look at a harder example. I left our original example up here, kind of the easy intuitive example, but now we have a risk score of 1.2 and 2.7. How would we solve for that? We're going to take however much we're going to invest in stock A and multiply it by the risk score of 1.2. Plus, however much we decide to invest in stock B, multiplied by the risk score of 2.7. What that's going to equal is our total investment times the risk score that we want the overall portfolio to have, 2. We're going to use that logic. We're going to go back and we're going to write the risk score for this example. For trade credits, we have a risk score of 1.7. For corporate bonds, 1.2, 3.7 for gold, 2.4 for platinum, 2 exactly for mortgage securities, and 2.9 for construction loans. We want that to be less than or equal to, we want the average risk score to be 2, and it's going to be 2 times whatever our total investment is. Where is our total investment? H8. It could be $5 million or it could be less than $5 million. So we want the risk score to be multiplied by however much our total investment is. We're ready to write our last 2 constraints. They're greater than equal to constraints. and it's on precious metals. We're told that we have to have at least 30% of our investment in gold and platinum. So we have to have at least 30% times how much our total investment is, H8, has to be in gold and platinum. And we're told that we have to have at least 45% in trade credits and corporate bonds. So it's going to be at least 45% times H8. Now that we've written our constraints, we're ready to solve it. We're going to Data, Solver. The objective function is in green. That's the amount of return that we're expecting. Obviously, we want to maximize that, so we're leaving it as maximize. The variables that we want to change, those are the variables that we are solving for. That's the yellow area. The constraints that we have, we're going to add all of our less than constraints first. So H8 through H15 has to be less than or equal to J8 through J15. We're going to add that constraint. Now I'm going to add my greater than constraints. H16 through H17 has to be greater than or equal to J16 through J17. That's the last constraint that I have, so I'm going to hit enter. We can't have a negative amount of money invested, so we'll make sure that we have the unconstrained variables non-negative clicked off. I want to call your attention to the solving method. You want to make sure that we're doing a simplex linear programming. Sometimes the default has changed on me as I've been working through the problems. So you want to make sure that the solving method that we're using is simplex. Go ahead and solve. We're going to tell it OK. What do the pound signs mean in Excel? Pound signs are when the answer, the value in a cell is too big given the column width that you have. So what I'm going to do is highlight all of those columns. I'm going to double click between column B and C, but you could do it between any two columns. And what that will do is it will automatically increase the width of the column so that you can see the full value. The first thing we should look at is how much money are you actually investing? We had to invest less than or equal to $5 million, and we are in fact investing the whole $5 million. So all of the constraints that we wrote, 25% of our investment, 40% of our investment, it is in fact going to be off of the $5 million. How much are we investing in each instrument? $1.25 million in trade credits and corporate bonds, $250,000 in gold, $1.25 in platinum, $500,000 in mortgages, and another $500,000 in construction loans with an expected return of $520,000.